An air rocket leaves the ground going straight up with a velocity, and reaches a height of 37 meters before coming back down. It's like going to tell us the velocity. No, they didn't. Okay. Neglect air friction. Use G as 9.8, right? We're almost certainly going to use negative 9.8, but that's okay. Okay, so let's see. 37 meters before coming back down. So let's draw a picture of this. Here's this rocket. It goes up, right? Goes down. Remember, it's going to spend half the time going up, half the time going down. Total time in the air is 2 times to the top. Final velocity is negative the initial. All these little clues, right? Velocity at the top is 0, right? So I'm going to solve this from the ground to the top. And that's the key. That's what we want to do. Because the 37 meters is at the top, right? So let's do this ground to top. X, VI, VF, A, and T. And we'll have to be clever about the total time it's in the air, okay? So our X from the ground to the top is that we go up 37 meters, right? Our initial velocity is kind of what we'd like to know, but we don't, right? Our final velocity we know is 0 because it's at the top, right? And then our acceleration is down 9.8, right? So we're making the downward direction negative and upward positive, okay? All right, so I guess we want to solve for the initial velocity, and I want to use a formula that doesn't require time because I don't know it. And that is, of course, Vf squared is Vi squared plus 2ax. So 0 squared equals Vi squared plus 2 times negative 9.8 times 37. Okay? And so 2 times negative 9.8 times 37, that's negative 725.2. So we've got 0 equals Vi squared plus negative 725.2. So I'm gonna add 725.2 to both sides, right? And I get 725.2 is equal to Vi squared, right? Notice that now it's positive because you put it on this side, right? And then I'm going to square root both sides. Raised to the 0.5. Or you can go second answer, second square root. Okay? And I get 26.9295. 929537. So our initial velocity is that it started off going positive 26.9 meters per second. When it strikes the ground, by the way, it's going negative 26.9 meters per second, right? Then it says, what is the total time it's in the air? Okay, so I'm going to use this guy here. I'm going to say VF is VI plus AT, right? So final velocity is 0, initial velocity is 26.9296 roughly, right? Plus negative 9.8 times t. And this will give us the time to the top, and we're going to have to multiply by 2, right? Total time in the air is twice the time. And this is in your little reference sheet, right? So I'm going to take that 26.9296, right? Okay. And I'm going to divide it by 9.8. And I get that it's about 2.748 seconds to the top. It would take, of course, 2.748 seconds to get down, right? So I'm just going to multiply that by 2. And I get the total time in the air is 5.4958, so 5.50 seconds. Okay, so just remember that the total time in the air is going to be twice the time it takes to get to the top. Don't forget that, right? So total time in the air, in a problem like this, we're solving it from the ground to the top, but the total time in the air is going to be twice the time it takes to go from the ground to the top. Okay.